Here we go again. I'm going to go over section 3.4. I'm going to do some of the guided questions. Now, these are the questions that you should be writing down on your notes. So I'm going to do most of them. I'm not going to do all of them, but I'm going to do most of them for you right here, right now. So 3.4 is all about multiple step inequalities, and we treat them the exact same way we would treat multi-step equations. We just need a graph at the end. So we need to solve and graph. Your whole goal, again, students, is to get the variable all by itself on the left with any of the inequality symbols in the middle, and then whatever your boundary number is on the right. So this is what we want. Okay, every single time. We want variable, symbol, number. All right, here we go. Two-step equation. All right, or sorry, two-step inequality now. So this process should look kind of familiar here. So I'm just going to go ahead and add 7 to both sides. I got a negative 6a still, less than or equal to, looks like it's going to be a 24. Divide by a negative 6. Remember, friends, when we divide by a negative, we must flip the symbol. A is now going to be greater than or equal to a negative 4. Let's graph that. Rough graph line. Negative 4 is my boundary number. I need a solid dot, and I need to go to the right. A is greater than or equal to negative 4. Remember, keep in mind, when you multiply or divide by a negative, the symbol must flip. Okay, what about other ones that are multi-steppers? Well, this one's kind of a big, huge mess. And this is the Got It question number 3 on page 188. By the way, I kind of have them highlighted on what I'm doing here. Again, these are the problems that should be going on your notes. So if you missed class, you have no excuse to miss the notes. Okay, I'm going to do 2 moves in one here. First move, I'm going to go ahead and subtract this 5 from both sides. Okay, and at the same time, I'm going to distribute this negative 2. So let me rewrite all of my work here. 15 minus a 5 is a 10. Less than or equal to negative 2 times a 4m is going to be a negative 8m. Negative 2 times a plus 7 is going to be a minus 14. Okay, let's do some more solving here. Looks like I'm going to add 14 to both sides. I'm going to have a 24 less than or equal to a negative 8m. Divide by negative 8, and I'm running out of space. So divide both sides by negative. I must flip the symbol. So 24 divided by negative 8, I believe, is a negative 3. Flipped the symbol. I got the variable by itself. Now, so close. We did get the variable alone, but it's not on the side we want it to be. So again, the symbol is going to flip. Now, when you flip the items, you need to flip the symbols. So there you go. Let's graph that dude really quick. Solid line, negative 3, solid dot, going to the less than, right? So again, students, keep in mind that when you are dividing by a negative, you need to flip a symbol. Now sometimes, in this case, it's kind of mean here, you need to flip the symbol again because the variable's on the wrong side. So just to give you a heads up, if you're looking for patterns here, if you have a negative variable, you're probably going to have to deal with some type of flipping because negative variables are connected by multiplication. Or sorry, the negative number is connected to the variable by multiplication. That means you're going to have to divide to disconnect it, and that's just going to end up with a flipping. When you have a negative variable on the right, it's going to flip once and then flip a second time if you want to write it correctly. So you're kind of right back to where you started. But you'll see that pattern the more and more of these you do. Okay, moving on. Next example, what happens when we have variables on both sides? Variables on both sides. This is the 4A Got It question, so take a look at this one right here. So the whole idea when you solve equations like this is you wanted to get rid of the smaller variables, so let's do that. 3b, negative 2b, that's an easy decision right there. I'm going to add 2b to both sides, so 5b plus 12 greater than 27. The reason we do this, I'm going to try to talk about something else and solve at the same time. The reason we do this, the reason I always told you to get rid of the smaller variable is because I always want you to have a positive variable left over. If you have a positive variable left over, like in this case 5b, you never have to worry about flipping the symbol. Okay, the only time you got to worry about flipping the symbol is when you have a negative variable. Negative variable, we had to flip. Negative variable, we had to flip. Positive variable, we have absolutely zero concern about flipping our symbol. Okay, so if you always attack the smaller variable, if you always get rid of the smaller variable, you will always have a positive variable to deal with. And if you always have a positive variable, you never have to worry about flipping, ever. Okay? Graph it really quick. 3, open, that way. All right, here we go. The other thing that could happen when you have variables on both sides is the variables could cancel, okay? They could cancel. So here's the 5a got it and the 5b got it. So what happens when the variables cancel? What do you mean when the variables cancel? Well, when you have the same variables on both sides. Okay, there's a 5n over here and there's a 5n over here. So right away you're like, what should I do? Your brain should automatically think, well, something weird is going to happen. And you're right. Something weird is going to happen. Try to cancel the 5s. Look at this. You've got a 9 is less than or equal to a -1. Just like with the equations, when the variables cancel, you're left over with a true or false situation. This is entirely false. 9 is not less than or equal to -1. So this would be a no solution situation. Okay, this is never going to happen. Okay, you are never going to have a number over here, no matter what you plug in. You are never going to have a number over here that's going to be less than or equal to -1, ever. Okay, so it's never going to happen. So ask yourself true or false. If it's false, you say no solutions. Spoiler, this one might be true. Combine like terms. 8 plus 6x is greater than 6x plus 2. Okay, to use your logic, friends. Oops. 6x's will cancel. 8. Is 8 greater than or equal to 2? Absolutely. So this is what you'd say all real numbers, but you all know me. I like to just say all numbers. Everything's a solution. Everything's going to work. No matter what you plug in, this side is always going to be bigger because it's plus 8 on this side. Plus 8 is always going to be bigger than plus 2, no matter what you do. So that's it, friends. The biggest things to worry about is just doing your proper algebra solving skills. You get rid of the weaker connections. You do the same thing to both sides. Just be careful when you have a negative variable because the symbol will flip. Negative variable, symbol will flip. If you got variables on both sides, get rid of the smaller one. You won't have to worry about flipping. If the variables cancel, ask yourself true or false. If it's false, no solution. If it's true, all numbers will work. Okay, that's it. I'm out. Bye-bye.